So hello everyone and welcome to the last session of today of our Digital We Days. Last, not least. Not least. I'm very happy to welcome all of you and that you took the time to participate in our webinar today. I'm very happy to welcome you, Timur, and yeah, happy to do the webinar with you today. Our topic is the introduction of the MagI³C Module Designer in Redexpert. So we are having a little live session here. And yeah, so just a few information from my side in the beginning. You will be muted during this webinar. This means that you cannot ask us your questions with the microphone, but you have the opportunity to ask us all your questions with the Q&A function in the WebEx control panel. You will find that on the lower right-hand side of the WebEx panel. If we can't answer all your questions within this live webinar, we will answer them later on, or Timur will answer them later on via email. And if you have any questions left after the webinar, just email us at digital-we-days@we-online.com. You will also get a link to the presentation as well as to the recording from us in the next few days. And also you find all that information on our website. So now for the beginning, I'm ready with all my things, and I'm happy to give the ball to you, Timur. Have fun, and I wish you an exciting webinar.
Thank you, Marcus, for the introduction. So let's start. So today I want to give you an overview about the new Redexpert tool, MagI³ Power Module Designer. So first of all, the base of the MagI³ Power Module Designer is the well-known design flow section that is available in every Power Modules datasheet. Here, as you can see in the slide, you can select the output voltage, input, output capacitor, feed-forward capacitor in this example, but also many, many more. So the MagI³ Power Module Designer is, if you summarize it, our philosophy, a quick and easy design-in tool for you, and you do not need any detailed DC-DC converter knowledge to get to a fully functional design. Basically, all parameters that are selected or can be selected and can be simulated, calculated in our design flow section can also be selected and simulated in this new tool. Additionally, the finished design can be downloaded as a PDF, and also the bill of materials can directly be sampled out of the tool. But here we have to make a note, the MagI³ Designer is currently only for the design-in. EMC experts like filters or something else is not mentioned here, but we will work on this. So where can we find the new MagI³ Power Module Designer? It is directly located on the top after the EMI filter design entry tile. If you open the MagI³ Power Module Designer, then you will see a starting screen. The starting screen here is, let's say, it is divided in three special sections. Section 1 here on the left, then we have got the second section, and above the third section. So what are the sections all about? First, section 1 is where you fill in the values of the parameters for your power module and for your application. Section 2, here you will get a recommendation about the power module that fits best for the values and the parameters you have selected. And the third section is the overall navigation section. Here you will see where are you in your current simulation design flow. So, to get a better overview, let's make a real example to show you better the functions of the MagI³ Power Module Designer. Let me choose here an input voltage minimum of 4 volts, an input voltage maximum of 36 volts, and set the output voltage to 3.3 volts. Please note here that the output voltage has always be lower than the minimum input voltage. To finish here, we have selected an output current of 200 milliamps, and we do not tick at the isolation voltage. If we now let the system run, we get 4 suggested power modules that fit best for the given values. We can check now each candidate individually by checking the rough specification we have on the bottom. Here, the rough specification. We can also go here and check the data sheet of the power module we want to select. Here we have also a CGI picture of how does the power module look like. And here what you can see is this is the typical circuit diagram, so that you see what, let's say, additional components you'll need, like a C-in, C-out. Then here you have got the RFBT, RFBB for the output voltage to adjust. And if we go now for the one I have highlighted here in red, our VDMM module, then you can start the simulation in 2 different ways. First way, you click here on this white arrow in the selected power module, or you can also go here in our navigation bar and say next, please. What you can see here is the simulated power module based on the values you have selected. That means for the values you have put in here, like 4 volts, 36 volts and 3.3 volts and 200 milliamps, and the selected power module, you will get the typical circuit diagram here. You will get a first suggestion about the input capacitor, a first suggestion about the C-out, the output capacitor, and how the output voltage divider should look like for the output voltage of 3.3 should look like. Lower here, the simulated values, you will get all values like efficiency, the output current, the output ripple, and all the other values simulated based on your selected power module. Every red highlighted part you see in the typical circuit diagram, like here C-in, C-out, you can see it here, RFBT and RFBB can be manually selected by clicking on them, and then you can choose a different one if you do not want to follow the recommendations. For example, here I have chosen the RFBT here and want to choose another resistor. Default, we are at 100K here. We go for the E96 series. This is the one with 1% tolerance. But you can choose here also 102, 105, so the E series you can select here. If you then select another resistor, here, then you will see if we change from 100K to 105K, the output voltage here will change immediately at all points where it is shown, but also all respective values that are simulated are also changing on the fly. So there is nothing like it, you have to store it or have to do some other steps in between. On the fly, it will be changed so that you can see, okay, what influence has a change of the parameters you make directly to your typical circuit diagram, to the parameters you have here. After you have finished the design and you are confident with the power module and the resistors and the capacitors, then you get to this, let's say, summary page. And on the summary page, you can see that we will show you again the typical circuit diagram, the values you have selected. You have got here the bill of materials. We show here the input and the output parameters that are the most important. You will find here also some additional technical resources. That means you can download here also the layout data. You will see how the power module look like. And most important here is you have here something called print and free samples. Here you can directly click on print and you will get a PDF summary, a PDF report about all what you have simulated and put in. And if you click on free samples, then there will a context menu open here, and then you see all parameters that are available at Würth Elektronik, and you can directly sample out of the tool. The report here is available as a PDF, as already mentioned, starting here with the hard facts like the input parameters, the simulated values. Then you have got the typical circuit diagram here. Here we are starting with the bill of materials, and then last but not least, the dimensions, the power module, how does it look like, how is all the pads configured, how is the order code, and all the stuff is on there. So this is now a lot of theory, a lot of dry theory. I would think, let's check it in reality. Let's make a demo session here. So if we now go here and make a, let's say, make a demo session here, wait. So then you can see here the MagI³ Power Module Designer directly located under the EMI filter designer. Just a click on it, then you will see the starting screen. We can make here, let's say, for now, a name like, as I have it in my slides, let's call it HiVin project. So as you can see, you can name it as you want. If you then go here and say, okay, our application has to start at 5 volts, minimum input voltage, and click here, then this is the first fail-safe system of this tool. No modules available. Yes, of course, because here it kicks in that the minimum input voltage is greater than the output voltage. That means you have here to select, let's say, 3.3 volts, so that you get a selection, because now the minimum input voltage is greater than the output voltage. Let's go here and say, well, let's go for 38 volts as a max. Then we get 3 different products. This is our VDLM power module. As you can see here, we have also this typical circuit diagram. Here you have got the rough specification. We have got here 3.5 to 38 volts, 0.85 to 13 volts as output voltage, and 1 amp. So this is a series. That means here we have got 3 amps and here we have got 2 amps. So if we now check this one and run the simulation, then you will see here the results of the first simulation. That means we have got here a C in, a C out, RFBT, RFBB. And we also have here an optional step that you can here select the output, the switching frequency. That means this power module has the capability here to manipulate, to set the switching frequency. If we check now the typical circuit diagram, then you will see here we have, for example, C in. We have got here, let's say, 65.8 nanofarads. And in brackets we have got 2. If we click here, then you will see that the system shows me that, okay, we need here 2 caps that have been selected, where each cap has 33 nanofarads. The good here is that the system also takes into account that we have got a DC bias effect. And all this about ESR, this is all in the background calculated. If we now say, oh, I don't want to go for 2 capacitors, then you can go here and say, okay, choose another capacitor. And here you can see, we also give you here the information based on all this stuff like ESR and DC bias, what we have here in the background, how many capacitors you would need from another capacitor if you want to have the same performance. If we go here and say, let's take this one, then you can see only 1 is selected. So, and here you can see then also the resistor, let's say, all its features. That means what size, what type it is, calculated ripple current out of this. And here, as you can see, on the fly, it is integrated in this new typical circuit diagram. Let's also go for, and let's change the RFBT as we did it in the slides. Let's take 412. And as you can see, initially we go for 3.3 volts. But if we change the resistor to 412 kilo ohms, then we go for 3.41 ohms output voltage. So for now we say everything is fine, this is the design we want to have. Then we can go here, summary, and then you see the typical circuit diagram. You can see here your own chosen value and capacitor for C in. Here the self-chosen RFBT here. Also the output voltage has changed from 3.3 volts to 3.41 volts. You see here the bill of material. You see here the name and all the parameters of this project. And then I want to show you, if you go now here and say print, then you will see this is then the report you will get as a PDF. This is something you can then use for your documentation, that you have got all the facts about the power module, which input parameters, output parameters, which frequency you have selected here for the power module, and see what you have simulated, what you have designed. The bill of material you can see the package the dimensions, so that everything you need to go on with the real design. And also here, if you go for free samples, then you will see directly all items that can be selected from Würth Elektronik will be inserted here, and you can go for samples. So I think this is pretty enough for now. I think we now know how the tool is working, and I think I showed you also, I know a little bit quick, but the capabilities of the tool and how it is working online. So thank you, and yeah, I'm here for your questions.
So, yeah, then I'm back again. Thank you, Timur, for your presentation and for the live demo with Redexpert.
Thank you.
So yeah, as you have mentioned, now we would like to turn our attention to your questions. And just little info before we start right in. We would go, or you will also receive all the information with the presentation and a link you will also get from us to the recording. And yeah, we will send that to you in the next few days. So yeah, let's start with the questions. Timur, as first, is it also possible to simulate the EMI filter with the MagI³ Power Module Designer?
I see that this question was multiple times here. Also, do you simulate? No, currently it is not possible, but we are working on making more functionality for the customer, because as it also in your questions here, everybody knows that in the datasheet of a power module, the LC filter, the pi filter is included, and we're working on this to put this also in for the next update, the next version.
Okay.
So this will come, definitely.
Okay, that's nice to hear.
Yeah.
So there will also be some updates.
And yeah, this year.
So yeah, the next question, why can I only choose 1% and 2% resistors for RFBB and RFBT?
Good question. In the past, we have also a wider, let's say, categories of resistors there. But then we saw if you allow the customer to have, like, let's say 5% or more, then the influence to the output voltage is too big. So if you want to set up the output voltage correctly, also the tolerance of the resistor has to be very, very narrow. So there's no big variation in the output voltage. And this is why we said, okay, 1–2%, this is enough. Because if the percentage is getting too big, then it's not a very good value for the output voltage.
Okay, so thank you very much for the answer.
Yeah.
Yeah, then we have a look at the next questions. We see there are also some questions coming in. Just also the hint, if we can't answer your question now in the live webinar, we will answer all of them later on via email.
Here we have got something to the functionality.
So yeah, it's about, is it possible to get back to the starting screen during the simulation process?
Let's check this.
Yeah, I'm curious. Yeah, it seems easy.
It seems, yeah, this is something where we said, okay, we do not want to lock the system. If a design is always an iterational process. So you see something, and say, okay, summary, okay. No, I don't want to have this because I need too many extra parts. So let's go back to the simulation, or let's go to the starting point and let's say do something like, let's go for, I don't know, 5 volts to, or let's go a little bit, let's go for 3.5, like an engineer would do it, and go for 36 volts. And then you will see, okay, now I change only a little bit. The input voltage, I do it a little bit lower, 0.5 volts, and I reduce it from 38 volts to 36 volts, and I get a new power module that I can select. So this is why we said you can jump back to the start again and do it again and do it again, so that it is not somehow stiff locked and you have then to do all the entries again and start a new process. This is why we did it.
Cool to see. Okay, so then, yeah, I think time for the next and last question.
This I don't
Yeah,
need.
are the outputs short circuit proof?
All our, let's say, non-isolated power modules are short circuit protected. This is all in our data sheets. The isolated ones, we have some that are not short circuit protected, but we have also a lot of that are short circuit protected. But this is something, this is not reflected in the MagI³ Power Module Designer as it is, because we say if you want to have more information, check the data sheet, and there's a direct link to the actual data sheet, so that you can go for the first page where you have got all the features somehow condensed, reduced, what is essential. And if you want to have more, then let's say you can go here and have on the left side all subsections, all chapters that are necessary for the designer.
Okay.
Okay.
Then, Timur, thank you very much
Thank you,
for the
Marcus.
presentation and also for all the answers. So yeah, now we are at the end of the webinar. I hope you also enjoyed it, and thank you also for your attention. Then also again, thank you, and
Thank you, Marcus.
have a good day.
You
Also
too.
for you, have a good day and goodbye. Stay tuned.
Bye.